Okay, so this is the University of Melbourne's Ruth Bishop Building. It's named after the discoveries of the rotavirus and houses some of the most advanced electron microscopes in the world. Electron microscopes are highly sensitive, and vibration, noise, electromagnetic interference and temperature fluctuation can all impede their performance. So this is a building all about stability and isolation, a building that is a machine itself. It's located on the corner of Park and Story Street and takes up the final development site on the Bio21 precinct. This $19 million facility consolidates the microscopy assets of the Bio21 precinct and is the home of the new double aberration corrected VIC, which is actually more expensive than the building itself. The instruments have been used recently in coronavirus research and are generally used in the life sciences. Importantly, the new building creates an incredibly stable environment that allows these highly sensitive pieces of equipment to do their very best work in terms of image clarity. This is a closer-up of the precinct, just showing our neighbours, University High School and Melbourne Hospital. On our site was the original Veterinary Research Institute dating from the early 1900s. Would it stay or would it go? It's actually not heritage listed. While it's recognised as having cultural significance, it has not recognised for its architectural merit particularly. But we felt for the neighbourhood and for the precinct it was important that it stayed, and the university agreed. And so we made ourselves lives very difficult, but the building is an extension to what we call the VRI, the Veterinary Research Institute. We're intrigued by its history, and probably on the next slide shows the thing that we picked up as the key organising element of our new building, which was this central axis. As we found the site, we not only had this heritage context, we also had a fairly exuberant neighbour from designing on the right-hand side there.
Okay, so we started with the available envelope being a singular rational form as an extension of the existing VRI. And to keep the simplicity of the form was important to us in what is quite a visually competitive and busy arrangement of buildings. So we had multiple access requirements. And then our form responded to the geometry of the Stage 2B building, which allowed us to break the singular form and provide views in to showcase this building's function from the research neighbours and the new forecourt we are creating between the buildings. Internally, we started with the arrangement of the microscope suites on a central axis, informed by the original entry and lobby of the VRI building. This arrangement is also tailored to the site's EMI environment. The dashed lines you see here are the required clearances from moving vehicles and lift. Any large moving metal is a possible source of quasi-VC interference, which the microscopes can detect. And then overlaid are the internal workflow paths with direct access from the wet lab within the PC2 rated foundry. So here you can see the central lab control room, which is really one of the key innovations of this building. So there's a lot of program competing for space around each microscope suite, and the typical arrangement has been for a dedicated control room and a plant room for each microscope. So what we've done here instead is to combine the 6 control rooms, combine the auxiliary plant rooms, and place the plant over in a mezzanine level, which makes use of the sectional space, but it declutters the ground floor plane also, and it results in a far more space-efficient building, but also much more open space, and so the light and warmth and views of this facility are quite unique for the building typology. And here we have that lab control zone with the microscope suites to either side. And you can see it's very collegial, it's warm, and it's bathed in natural light from either end of the central axis. And the room also makes an excellent space from which to showcase and explain the instruments and the research that goes on here to visiting researchers, stakeholders, and the students. The view from Stage 2B into the building and into a suite, showcasing the microscopes themselves. The atrium also gives visitors an idea of the scale of the instruments and the care and protection they are afforded with the double height space and the structural depth expressed in the openings. The atrium expresses the height of the microscope suites as an elemental form, and we treated the other elements in the same way. So we have a collection of distinct sculptural and textural elements in a triple height space. In doing so, we're after the stairs to be a joyful experience and so the primary form of circulation, in preference to the lift, which is only for sort of BCA requirements and basically trying to minimise the lift as it's a possible source of EMI. On the mezzanine level, we have the dedicated microscope plant room as well as the building plant to the north. And then within what was a single level lecture hall, we've introduced a mezzanine office level for the faculty staff. Brickwork infilling the arches of the old lecture hall was replaced with windows, and so these offices have provided spectacular views over Parkville, as well as a sense of the historical facade from inside. The building plant has also been sandwiched discreetly within the mezzanine. And I won't go into the detail, just to say that the microscope's demand and services is substantial, and a lot of consideration goes into the briefing, but also into ensuring that each has the minimum possible impact on the EMI environment. And then above a real value add for the university, being the last development site of the precinct, we managed to fit in an office level that could be lettable to suit to the research partners of the university. So the building itself is a CLT structure, as well as reducing the carbon footprint. Using timber improves the EMI environment by removing conductive metal, which can host straight earth currents detectable to the microscopes. And you can also see here the structural isolation of those microscope suites. So the construction of each suite, you see the isolated footing ready for a fibreglass topping slab, again about removing conductive metal. The walls and the CLT lid are then built and they're completely isolated structurally from the main structure. And then within each suite, you have the low velocity air duct. You have the active compensation shielding, and you have the emergency extraction for nitrogen spills. Throughout the lab, there's natural light, views to outside, and connectivity between the workspaces. From the corner of Park and Story Street, the new windows into the lecture hall take advantage of the original arches, and the uniformity and matte tones of the screen create a backdrop for the lecture hall. The depth, shade and order of the screen also conceal the variety of program and plant contained within.
Yeah, so probably the best thing we've heard about the building is when we were doing the photography, we bumped into the person installing this new $20 million microscope who goes around the world installing the microscopes, and he said it was one of the best facilities in the world in terms of layout and its stable environment. We feel we've created a good neighbour in a complex environment, and importantly created a really uplifting workspace for the scientists to do their very best work.